So this pipe here is called FA Safe, Flow Assurance Safety, and in this setup we do more or less the opposite of what we do in the depressurization facility. Here we don't study what happens upstream of a constriction, but downstream. For CO2, the particular thing is that if you depressurize below the triple point, which is about 5 bar, dry ice is formed. And for the layout of processing plants and the safety systems, it's important to know that in case of an unwanted situation, you can lead the CO2 away without vent pipes being plugged. So this setup will give us the data that enable us to develop models and designs of safety systems of processing plants. So we have CO2 entering the tube here. It can be of high pressure. Then inside here, which you can't see, but you can see the handle is a throttling valve. So that CO2 is depressurized below the triple point and the dry ice is formed. And in the insulated section down here, we measure pressure and temperature in many positions to see if and where dry ice is deposited. After the experiment, we close both ends and we heat the section and measure the CO2 gas that comes out, and this lets us calculate the amount of dry ice that was formed. This setup is also very relevant for the Norwegian full-scale project, in particular for low pressure transport of CO2 in ships, where the transport point is quite close to the triple point, and it's of interest to know how much dry ice is formed in different situations. It is very important that models and experiments go hand in hand. You can't have one without the other. So experiments in themselves are only numbers in a column, and the models, if they are not validated, we don't know if they describe reality. So this is what we try to do here. Another important thing is that when we scale up CCS, for instance through the Norwegian full-scale project, it's important to have accurate descriptions of the CO2 phenomena so that we can make optimized and efficient systems. And we know for sure that our project partners are very eager to download our data sets, and they use it, for instance, for validating their own models. Another thing that we use these data for is to validate our own model that describes running inductive fracture. That is the fluid part of it, and we've had much interest from industry to use that model to evaluate CO2 pipeline designs.